particular part of trigonometry, or it's all of it? Do you know what I mean? Like, because there's trigonometry equations, and then there's trigonometry, like, visual problems where you have to find different sides. Where's the remote?
Just in general. I've forgotten, like, even the basics in trigonometry.
Alright, so we'll just do a little bit of everything then. Sorry, can anyone see where the remote is? You need to turn the TV on.
There it is.
Where? Oh, okay. That's strange. Right. Okay. Do you mind if I just flip this around? Will I do the first one on page 15? Like, you want to see this one? How to solve this?
Yeah.
Yeah. No, the only reason I'm asking you is because if you don't want to see it, I don't want to be wasting your time. So you're happy if I start with the first one there?
Yeah, because I've seen this in the past paper. Like,
it's a fairly common question in the past papers, this type, yeah. Alright, let's have a look at how to do this one. So, yeah, I'll just write it down. Cos 2 theta equals 2 over 8, and theta is between 0 and 180 degrees. Okay? Now, first thing, you want to make sure your calculator is in what mode? The degrees or radians? What do you think? You have a 50-50 choice here. Degrees or radians? Wrong way. Degrees. But why did I say degrees? Well, you look at this part and you can see that in the question they're using degrees. Yeah. So in this one we are in degree mode. Okay. Have you got your calculator? We'll put in degree mode.
I can't, because my calculator is stuck in press to test mode, and I need another of this models and connect them to each other to get out of that mode.
What on earth? Your calculator is stuck in a particular mode.
Yeah. I don't know how it got to that mode, but like, I'm in press to test mode, and
press
it says
the test mode.
it can only be in rads. So.
What a strange situation you found yourself in.
Yeah.
Press to test mode. What says angle settings degrees?
What? Well, one or the other is stuck in, and it can't get to the other one.
Okay, well it looks like it's stuck in degrees. So that's at least okay for today. Right. What do we do first? If you know, or any ideas? Forgotten? That's okay. So let me tell you what to do first. First thing, you use your calculator and you get cos inverse 2 over 8. Yeah, you're in degree mode?
Yeah.
Great. Oh no, just type in this here. Cos inverse 2 over 8. Yeah. What you get? 75.5. One more, please. 5. 2. Okay. Degrees. 75.52. Now just write that a bit smaller. Now, there's actually more than one answer here, okay? There's actually possibly up to 4 answers. And the reason I know this is because cos always goes in answers of pairs. I mean, you always get 2 answers. The problem is your calculator only gives you the first answer, not the second answer. And the reason I'm saying 4 answers and not 2 answers is because of this 2 here. It doubles the number of answers. Okay? So instead of having 1 answer, we could potentially have 4 answers. And now we need to learn how to find the extra answers. Okay? So for finding the second answer of cos, who was your maths teacher?
John.
So does Joan use this circle or not? No. No, that's fine, because there's two ways to do it. This circle means nothing to you. That's good, because then I can just show you the other way. There's a simple little table you can remember, or try to remember, to get you the answers. If you have sine, the second answer is the first answer on your it's 180 degrees minus the first answer on your calculator. If you're using cos, it's 360 minus your calculator answer. And if you're using tan, it's 180 plus your calculator answer. So, I want the second answer here. I'll just do 360 minus 75.52, please, and if you can tell me what you get.
284.48.
Okay, but that's only two answers, and I said there should be four. How do we find the extra answers? The good news is it's actually pretty easy. When you have two answers already and you want two more answers, you take these two answers and add 360, one full circle to them. So if we do 360 onto the first one and onto the second one, what do we get? Plus the 75.52. 435.52 degrees, and lastly 284 plus 284.48 plus 360. 644.48. Okay. There's only one step left. Or two steps really. These answers are for 2 theta, but we want the answer for theta. So what do you think we have to do to these answers? Divide by 2. So scratch that out and divide these 4 answers by 2. Okay, so if you don't mind, 1 by 1, dividing each one by 2. So we have 1, 2, 3, 4 then. So what's the first one then? Okay, so that's that. Okay, the next one then. Okay, so if I do 3 significant figures, I can round to that, yeah. And then I think the last one will do this. Yeah. Now, we're not quite finished, because if we go back to the question, they only want answers between 0 and 180. So we accept, reject, reject. And that's how we do this one. Okay, so it's not too bad, but you know, it's only 3 marks, so it's medium difficulty. Not the best and it's not the worst. Is that one okay for you?
Yeah.
And is it okay for you? Okay, so in a moment we'll have a look maybe at this one then, the next one. Okay? Alright. There's our triangle. This is A, that's 60. This is B, that's 12 meters. That's X meters. Okay. And we're also told the area. The area is 48 root 3 meters squared. And our first question is to find the length of BC. No, sorry, what am I saying? The first question is to find x. Okay, so there's two formulas for finding the area of a triangle. I wonder if you remember them. There's two formulas. The first one is the first one you learn in school, which is a half the base by the height. There is another one that has sine in it. I don't know if you remember that. If I say it, it might ring a bell. It's a half AB sine C. This is the other formula for the area. So in this one here, not to confuse you, rather than using the letters, I'd rather use the words. So the way it works is like this. To get the area of this triangle, you do a half times a side times a side times the sine of the angle between the two sides. That's kind of the rule in words. So here it's a half times 12 times x times sine 60. That's the area. But we're told what the area should be. It should be 48 root 3. So could we find x? We could. We do a little bit of cross multiplying and we can get the x. So the x will be 48 root 3 over, now a half times 12 is 6. So it's over 6 sine 60, yeah. And we can get the x here if you don't mind typing that in.
Is it 16? Does that make sense?
16?
That's what I got.
Yeah, right there. Looks believable. 16 meters then. You said 16, didn't you?
Yeah.
Not 60. Yeah, okay. Right. Now, the next thing we want to do is to find the side BC. So that's this side here. I'll just call this side A. Okay. This requires one of the two rules you might have heard about, the sine rule and the cosine rule. Now, how do we know which rule to use? It's basically like this. Most of the time it's the sine rule, most of the time. And the time when you need the cosine rule is exactly when you have this situation, where you have two sides and an angle. Or the other situation is when you have three sides and no angles. So the way the cosine rule works, it's a lot like Pythagoras. What you do is you say the missing side squared equals 12 squared plus 16 squared. Now if I stopped there, you would say this is exactly Pythagoras. What makes this not Pythagoras is the cosine rule has an extra piece. And what you do is, at the end of the cosine rule, you put twice minus twice, the two sides you just used, and cos the angle between the two sides. And you realise you're just one step away from the answer. If you square root this, then you have your A. Okay, so when you're ready, no rush, if you can type that in. You can write it down first. Got an answer there?
I mean, we were calculating now when it was in the square root and all that, right?
If you have the answer with it, without the square root, you can tell me what you have.
No, I have it in the square root and it's 17.40.
Okay, great, that seems fine. 17.40?
No, 435.
So if I do three significant figures, it'd be like this, 17.4, wouldn't it?
Yeah.
Okay, great. And the last part now is they want this distance here, if I could draw it for you on the picture, this height. Okay? Now, the easiest way I think to get that is to use the formula that the area is a half the base by the height. Yeah? So, in this one here, the area is 48 root 3. What's the base? That's going to be this number we just got here, yeah. A half the base, and the height is the thing that we want. So finally the answer will be h equals 48 root 3 over a half 17.4. We can calculate that then. Seems believable. 9.5 556. So that's 5 6 then. You're from Brazil, aren't you?
No.
No? What country are you from?
Finland.
Finland. Was there a student in this group from Brazil? No? Oh, okay. How did Finland do in the World Cup? Did they even qualify? Have you been watching the World Cup?
No.
No interest? Any interest?
Yeah, but I didn't watch the seven.
You didn't watch?
I didn't watch the World Cup.
Oh, you're not watching it?
No, I didn't watch that.
No interest?
I have interest in football.
What's your home country?
Zimbabwe?
They didn't qualify, right?
No,
They're not in it. No.
Yeah.
I think I would have noticed this. Zimbabwe I don't usually see in the World Cup, right?
Yeah. Sometimes they don't even.
That's okay. Ireland's not in it either.
Oh.
Okay, have we got this written down? Now, what's good is the next one here is going to use the other rule. So here we need the cosine rule. This question will need the sine rule. Now, I want to show you something that's really weird. You see that tiny little symbol on the 1.2? That looks like a degree, but if you look really closely, it's not actually a 0, it's a C. And that's kind of annoying. You have to be careful because that actually means radians, if you can believe that. Yeah, I know, it's crazy. It's really bad because it's so easy to mix up, okay? So that's a radian, not a degree, which means now your calculator is powerless to deal with this one. So if you put your calculator in radian mode, we can have a look at this one. Okay. No questions with this? Is this okay? Have you seen the cosine rule before? Is it understandable here? You get what I mean when I say it's like Pythagoras?
Yeah.
Okay, let's have a look at the next one. So, A, B, that's 1.2. That's 8.2 centimeters. 9.7 centimeters. And that's C. Okay. Find A. So this is where we use the sine rule. So the way the sine rule works is you pair an angle with its opposite side and an angle with its opposite side. So here you say sine A over 8.2 equals sine 1.2 over 9.7. Do you get what I mean when I say you pair? So like this one went with this one and this one went with this one. So I can make this equation. This is called the sine rule. And you realise it's not too bad to solve because you can now just say sine A equals 8.2 sine 1.2 over 9.7. So since you have a radian mode, can you tell me what we get on the right here? Huh? Can I see? Oh, well let me just retype it. 8.2 times 7.2 over 9.7. Sine A equals 0.7879. So how do I get A here? What do I use on my calculator to get the A? I use that button called sine inverse to work out what the A is. So that is 0.907 radians. Is this okay? You're not looking too happy with this.
Well, if I won't be able to calculate it because of my calculator anyway, so.
Well, you said you can reset it, can't you?
I mean, when I read through that stuff, it said like you have to connect it with the USB to another calculator of this.
Let's see again. Also, I notice your calculator keeps flashing at me as well.
It's because it didn't press the test mode.
That's the test mode flashing.
Mm.
Is it touch screen? No, sorry, it's not touch screen. So,
like there are settings, I can press that OK for another
ooh,
thing,
this
but,
has a little mouse on it. Sorry, I've been
Yeah.
distracted by it.
but it won't keep to that if you change the settings.
If you change the settings, it goes back to this test mode.
Yeah.
Is there any option that you saw online for how to like reset the calculator? Do you know what I mean? Like a factory reset?
I don't know. I didn't really check. I know that this came with a CD, but the CD's back home, so.
I would say you just want to go to Google, type in the name of the calculator and type in factory reset. Because there's usually some way to reset calculators back to their, their like default settings when you buy it new. I can't see where it is in the settings here. It might be a hidden option or something. Anyways, try doing that. I'm sure there's a factory reset you can do. But right now I can't exactly see where it is in the... Oh, it has a keyboard as well.
Mm-hmm.
What's the point of the keyboard?
I don't know. I mean, I can also use the calculator to convert to like meters to feet or feet to meters and grams to whatever.
I see. This is quite fancy. Did you
Yeah.
have to...
In high school, I took advanced math and we needed those, so.
Yeah, that's what I was going to say. This is part of your math class. Is it like how they do it in the States, that you have a test where it tests your ability to use this? Because in the States they have like a maths exam where the first paper you can't use the calculator and the second paper you have to use the graphing
It wasn't
calculator.
like a separate test. We just had that calculator, and then we also had a formula book that we could take with us to test, and then we had the finals were like a 6-hour test, and we just did that.
Okay, and the calculator you had for the test then?
Yeah.
Yeah, and some of the questions you needed
Oh yeah, well I mean, I switched from advanced math to non-advanced math after the first year, but like, in advanced math, yes, you have to use the
You
calculator.
have to use it. Okay, okay. That must have been pricey.
There was a discount because my high school paid a little bit of it, so it was like €70.
Still, pricey.
Yeah.
Pricey. Okay. Now, we've done 3 examples, and the good thing is those 3 examples are typical of what you get in the exam. An equation, a cosine rule, and a sine rule. So I can do another trig one, but maybe we should do a harder one. Like for example, do you see the one on page 18? There's a double triangle. It's a bit harder. So let's have a look at that one. I'll draw it here. So we've got this one. P, Q, R, 12, 55 degrees. S, this side is 14 centimeters and this is 72. Oh. Dear, I've been sneezing since yesterday. Okay. Now, let's have a look at this one. I think, are we told the area? No, we're not. Find QR. Okay, and that's 12 centimeters. So I just want you to tell me which rule I need to find QR, which is this side. I'll just call it the letter P. Do I need the sine rule or do I need the cosine rule to find P? And I'll circle what we have. We have this, and we have this. So what do you reckon?
The
Cosine rule, very good. So maybe you can tell me what I need to write down. So I write down P squared equals what? 12 squared, yeah.
14 squared.
Yeah.
And 55.
No, not quite 50. Before there's something before the cough, you're half there. There's a 2.
2 times 12.
Yeah.
14.
Yeah, and now
Cos 55.
Cos 55. Okay, very good. So once again, taking out the calculator.
12.14.
Yeah, no, 12.14 seems believable actually. It should be similar to 12, they're about the same size. I wasn't expecting it to be so close, but that's actually, that's fine. 12.14 centimeters, right? Yeah. Okay, the next one now, they want this angle PQR, which I'll call theta. Now, what rule could I use to get the theta? Could use the sine rule, because what you can do is you compare the theta with the 14 and the 55 with the p that you just got. So you can make this equation. You can say sine theta over 14 equals sine 55 over p, which is 12.14.
Why do we make that a theta?
We can call it any letter we want.
Okay.
Yeah, I just want to give it a letter. You don't like my theta? It's a bit funky looking, I know. You could, actually, do you know what, sorry, they already provide a letter, they called it Q. You can call it Q if you want. Anyways, sine theta, or Q, is equal to 14 sine 55 over 12.14. Alright, so sine theta equals, what do we get for this if we bash it in? Negative. Are you in degree mode?
Okay.
There you go.
Okay.
Problem solved.
0.94.
That seems fine. 0.9. Give me two more decimal places, please.
0.94465.
46. Okay. And then, since well, if you have that on the calculator, if you could do sine inverse now, we can get to theta. Say again?
70.84.
Okay, 70.8 then. Seems fine to me. Yeah? Okay, now the last part. They tell us, oh sorry, I'll give you a minute to write this down. Okay? Yeah? Okay, the last part is they tell us that this area is twice as big as this area. So first, let us get this big area. We can use the rule 1/2 12 times 12.14 times sine, what did we just get? 70.8. Now just so you're clear, what I'm doing is I'm doing the rule 1/2 side, sine the angle. That's the rule we had in the last question for area. Can you tell me what that is, please? Okay, now, if that's the area for the big triangle, then the area for the small triangle should be half of this, because they say it's half. So what's that going to be if we half this number? 36.38 centimeters squared. Okay, so what's the rule here for area of this triangle? Well, it's the same story. 1/2 side, this side is 14, and then this side, which I don't know, I'll just call it x. This is the side they want us to calculate. So it's 1/2 14 times x times sine 72. That's supposed to equal 36.38. Could you just work it out there? So that's kind of it, really. We can get our answer. X equals 36.38. 1/2 times 14, of course, is 7. So over 7 sine 72 equals. That seems believable. 5.46 centimeters. Okay. Let's think now. I could do more trig, or if we've got time to do, we can do another calculus one. It's your call now. We've got time to do another question or two. I've kind of done all the basic. They're not basic. All the, what's the word? Not basic. All the key or typical trig questions in the exam. Sine rule, cosine rule, area, and equations to solve. So we've done one of each. So that's kind of all the trig, really. We can do more examples if you want, or we can look at another topic you would like to see a question or two on. Yeah, what do you think? Go and have a look there, yeah. Yeah.
I guess page 133, there's this one, this V4, B3 down here.
This integration, is it the, yeah, this one's the one you're talking about, isn't it?
Yeah, 'cause I've seen that in other ones.
That's common enough, we can do that one. Because I think last time we were doing derivatives. I don't remember if we did, or maybe we did a bit of integration. So we'll do this one. Explain what your answer means after you get the answer, and then show that this crosses at this point here. Okay, so let me just write that down. Sorry, can you see it at page 33? I'll just write it down here. I got it here, it's okay. Firstly, we want to integrate minus 1 to 0. Is that x cubed minus 6x squared plus 9x plus 1 dx. Okay, so there's go there. Yeah. Okay. So, in your formula book, I can show you if you have your formula book with you. Do you? Yeah. I know. I just want to show you where this is in the book if you have your book. Yeah. There's a page with integration rules on it. Yeah, here it is here. So, do you see? This is the integration, and the rule is if you have x to a power, as long as the power is not minus 1, x to a power, what you do is you make the power 1 bigger, and you divide by that 1 bigger power. Yeah. So here, this x cubed will become x4 over 4. And then this will become 6x cubed over 3. Now this is actually like 9x1. So this becomes 9x squared over 2. And what does 1 become? Well, if you want a little help, 1 is kind of like x power 0. Because x power 0 is 1. So this becomes then, Rowan, you're outside there. Come here. A little bit early. Do you want to sit down?
Can I?
Of course. I'm sure they don't mind.
You know,
You don't mind, right?
No.
No. Plus x power 1 over 1 then. We're doing an exam question if you're interested. So this is a integration one here. Okay. Now, do you know what I do with the 0 and the minus 1? Replace them. Now, which is the order? Which goes in first? The 0 or the minus 1? Yeah, the 0 and then what do you do with the two answers? Yeah, because you put the 0 in, you get an answer. You put the minus 1 in, you get an answer. And then what do you do with two answers? Well, you have a couple of choices. For example, do you add, subtract, multiply, or divide the two answers? You think you know. You look like you know. You've got 1 in 4 chance of guessing it right. Add, subtract, multiply, divide. Which one do you think it is? And look deep inside. Pick one. What are you going to pick?
I was going to say multiply.
No. Subtract. Subtract, yeah. So we put in the 0 first, and we'll get 0, 0, 0, 0. So all 0. All 0. Then we put in the minus 1. So you can do this on the calculator. I think you'll get 1 over 4 plus, this I think will be a 2. This will be a 9 over 2, and this will be a minus 1.
We are subtracting 0.
Yeah, it's going to be 0 minus whatever this number is. Can you type that in? Tell me what you get. 2 1/4 plus 4.5, 6.75, 5. Is it 5.75? You can tell me. It is? Wonderful. Well, this is easy to subtract, so the answer is minus 5.75. Yeah. That's part 1. Part A. Part B. What the heck does this answer mean? Now that's a harder one. And it's probably only like 1 mark.
Yeah.
So, this is what's happened, okay? Oh, sorry, do you need to write this down?
Yeah.
Do you know what integration represents on the graph? So like, this is a graph of a cubic. So, what does the integration represent? The integration represents the area. So, that thing you just calculated, you did it from, what was it? What was it that you did it from? -1 to 0. You got a negative answer. What that means is the area is mostly negative. What does negative area mean? When the graph is under the x-axis, we say its area is negative. And then when its graph is above the x-axis, its area will be positive. If I combine these two together, which do I have more of? More negative or more positive? Well, more negative. So what the answer is telling me is that most of the area between -1 and 0 is under the x-axis. Yeah.
When we take the for this
Integration?
yeah, the number, the calculation doesn't get this.
Oh, the 0 here?
Yeah. One article 1/4 goes to.
Oh, I replaced the x with -1. I did it in my head. I hope that they're each right. What would happen in the exam though is you would just type all of this in one go and just get this number.
Oh.
It's because I didn't have a calculator, I was doing each little piece in my head, that's all. Okay, last part now. Can you just read the last part, or if I can just flick it around here. You have a curve, y equals x cubed minus 6x squared plus 9x plus 1. Show that this curve crosses the x-axis. Oh, okay, that's nice. They want you to show that the root is between -1 and 0. That somewhere between -1 and 0, there's a root that crosses the x-axis. This is very easy to do. All you have to do is calculate what you get when x is 0 and when x is -1. And if one of them is positive, and if one of them is negative, then we say there's a root in between the two answers. So if I put in 0 into this, what do I get? I get 1. Wookie, you can come in. You can sit down. If I put 0 into this, I'll get 1. Oh no, I didn't say you could come in. Just Wookie. If I put 0 in, I get 1. And if I put -1 in, I'll get -1, -6 is -7, -9 is -18, plus 1 is -17. So, opposite signs imply root in between. And that's the 2 marks. Okie dokie? Right, we'll wrap it up there. If you want to see me for questions, I'll be in the office. I don't have any classes on Monday. The same goes for you guys as well. You can find me on Monday in the office if you have questions. Okay? What class you got now?
Biology.